Okay, so like I said, we just wrapped our head around what surface area means, and now we're going to start talking about volume. Now, surface area and volume always get talked about at the same time because they both are calculations that have to do with 3D solids, but they are totally different types of measurement. Okay, so it sort of bothers me that we teach them at the same time because it gets confusing. People get surface area confused with volume all the time. Just like perimeter and area. Okay, perimeter and area are two entirely different measurements, but we always teach them at the same time, which makes students think that they're really similar to each other. Okay, surface area and volume are the same thing. They're two entirely different ways to measure a figure. What does volume measure? Rachel.
It's like on the inside of the whatever it is.
Okay, so it's a 3D solid, and it's the space on the inside. But it's three-dimensional space. So you know how area we measured in squares? Like when we were finding the area of a figure? Right. If we were finding the area of a figure, what you're really finding is how many squares would fit inside that figure. With volume, you're finding how many cubes would fit inside that figure. So definition, a measure of the amount of space inside a three-dimensional figure. Oh, did I leave that on there for you? Perfect. And it's measured in cubic units, meaning you're counting cubes can fit in something. So if you had a rectangular prism like this, and I said find the volume, what you're really finding are how many little cubes. Think about them as little building blocks. How many building blocks would it take to make that figure? This picture in there too, because remember I talked about wrapping a present for surface area. Surface area would be like how much paper does it take to cover the outside? Okay, it's flat. It's how much surface there is. Volume is how much space would there be inside the box for whatever it is you're trying to wrap. Okay, so I have a lot of people say like, well, surface area is the outside, volume is the inside. That's sort of an oversimplified way of thinking about it, but that is true. Okay, so what I want you to do is think about, especially when we're talking about prisms and cylinders, think about them as a stack of flat shapes. So for example, let's say this stack of paper was a prism, right? Because that's what a prism is, right? It would be like a rectangle on the bottom and then solid all the way up. So imagine this is a rectangular prism. Then couldn't I find the space by finding how much space there is on one of these sheets of paper? Yeah. And then just multiplying by how many sheets there are? Does that make sense? Mm-hmm. So that's what volume really is it's like you're going to find how much space does one of these sheets of paper have, and then how many are there in the stack, which the how many are there in a stack, that's really like the height. Okay, Jake?
Like when we're talking about volume, is it like the inside, like inside the walls, or is it just including the walls? Like?
It's, well, technically, in a perfect world, the walls would not have any thickness. So I see what you're saying. So it goes up to the walls, but we assume that the walls don't have like thickness to them. Okay, so it kind of goes to the boundary. Does that answer your question?
What I'm thinking probably won't work. I was thinking, like, say for a cylinder, would you find, if you found the area of the base and then multiplied it by the height, that wouldn't work?
That's exactly right.
Oh.
Yes, that's exactly what you're going to do. So like if you think about a cylinder, stack of pennies, that makes a cylinder, right? If you stack them up perfectly, that would make a cylinder.
Yeah.
So if I found the area of one of those pennies and then multiplied by how many pennies there were in the stack, that's going to give you the volume. So that's exactly right, Hunter. Same thing here. I could find the area of, whoops, I just need one. Area of one of these rectangles, and then, which you know how to find area of a rectangle, right? And then multiply by how many there are in the stack, which is the same as the height. Okay? So I think for you. Did I? Okay, good. So you find the area of one of the shapes, which is the base, and then multiply by the number of those shapes in the stack, which is the same as the height. So maybe take this number in the stack and like underline it and write height underneath it or something like that. Okay. Okay, yeah. And I want to talk about that. Right. So that is like a, I guess technically it's a formula, but it's a very general formula, okay? This big capital B, that stands for area of the base. And so you're going to want to mark that down for yourself. Because I have a lot of people who just think that that's one number. Like they should be able to look at a shape and say, oh, the base is 5. Okay? This B, whoops, sorry, I thought I had a pencil here. This B is the area of the base. Okay? So that's important because if your base is a circle, then you need to find the area of the circle. If your base is a rectangle, you're going to find area of a rectangle. If your base is a triangle, you're going to find area of a triangle. So there's all different kinds of math that goes into figuring out what that B is. And then you just multiply by the height. So volume is a little less complicated as long as you don't skip over steps. Questions on that so far? We're just going to work through a bunch of examples. We're not going to get through all of your examples today. I think there's 6 of them. We'll get through all of them. So, volume of the cylinder. Somebody tell me the first thing I want to do. Go ahead, Hunter.
Area of the base.
Okay. So, it's a circle. Okay. So, area of my base is going to be pi times my radius squared, pi r squared. That's 16 pi, which I believe is like 50.25 maybe? 26, thank you. Okay. So I found the area of my base. And then what do I do to find the volume? Okay, so take that 50.26 and multiply by the 15, which is the height of the prism. Say it again.
753. Just do 754.
754. Come on. And these are being measured now in cubic units. Okay? That's another thing. As soon as I teach you cubic units, people want to go back to surface area and use cubic units for surface area. Surface area is still squares. Even though you're working with like 3-dimensional figures. Still squares, so it's still square units. Volume is the only one that's cubed. Bryce?
On the exam, or like the test or whatever, if you put CM2 by accident, would you mark that wrong, or like half off? Just don't do it.
Technically, yes. But I have to tell you, my official answer is yes, I would mark you down for that. My unofficial answer is I'm way more concerned right now with whether or not you can do these calculations. Okay? So it is important that you get it, but I don't get too harsh about that. I should, but I don't always. Tricky here. We've got a triangular prism laying on its side. Okay, so what do I want to find the area of when I'm trying to find the area of the base?
Rectangle.
Okay, glad you said that. If I found the area of the rectangle and then stacked up those rectangles, is that going to make this shape? This shape is really a stack of what? It's really a stack of these triangles, right? It just happens to be laying on its side. Okay? So this is a prism. This is a triangular prism, which means the triangles are really my bases. Like if I asked you for lateral area, because we just finished that. If I said, find the lateral area, wouldn't it be the triangles that you leave off because the triangles are the bases? So even though it's laying sideways, the base is still the triangle. So you want to find the area of, I don't know why I keep pointing when I could be drawing. You want to find the area of the triangle and then multiply by how many triangles there would be. Okay? So be careful of that. How do I find the area of that triangle?
9.5.
Good, 9.5 times 5 divided by 2. Oh gosh.
3.75.
Thank you. I was almost there. So area of the triangle is 23.75. And then to find the volume, I scribbled over my number. Is that a 12?
Yeah.
Okay. I would do 23.75 times 12.
285.
285? And again, that's cubic centimeters. Okay. Does everyone understand why I went that route? Why I did the triangle instead of the rectangle on the bottom? I know that when you think base, you wanna think about the shape on the bottom, but I can't stack these rectangles up and make this figure. I could stack these triangles up and make the figure, it would just be like a sideways stack. Okay, Jake?
Oh, when I did it, I must have did it wrong, but I doubled the base, because there's two. That's what that happened.
Oh, yes. This, when you find the area of one of these and then multiply by how many there are, that's gonna include that other one on the end too. So yeah, you don't wanna use that base twice. I know why you're thinking that, but if I say this is a stack of 100 sheets of paper, okay? And I find the area of one and then multiply by 100, wouldn't that also include the one on the bottom, right? So you don't want to include the base twice, because you're already including it. Was there another hand? Thought I saw another question. You good? Okay. Okay, this one's a little trickier. The volume of the cylinder is 78.5. Find the height of the cylinder. Okay, so the height is what I don't know. I'm going to just mark it H. And what I would do with this one is I would just proceed through it like you normally would until you get to the point where you can go no further and then solve it like an equation. Okay, so what would our first step to finding volume be? What would be the first thing we would do to find volume? Marty, go ahead. Okay, so we're going to do area of that circle down there. What is that, a 5? Okay, so how do I find area of the circle? Okay, so pi times the radius would be half of 5, so 2.5 squared. 19.6. Okay. What would our next step be? Okay, so the volume should be 19.6 times H, right? So I don't know what H is. Caleb, will you put that away? Put it away, like where I can't see it. Thank you. I don't know what H is, but what do I know? The volume. I know the volume should be 78.5. So I'm going to take out this V and make it a 78.5. Not subtract. What would I do? Divide. This is saying 19.6 times my mystery number has to equal 78.5. So I want to get rid of this 19.6, so I just have H. And the opposite of multiplication is division. So I'm going to divide by 19.6. Say it again?
4.005.
We'll just say 4. So our height's about equal to 4, and that would be 4 inches. Okay. Because probably what happened there, it probably should be 4, and just because we rounded off that 19.6, that's probably why it came off a little bit. Does that make sense? Questions, problems? Okay. Okay, here's another one like that. Volume of the prism below is 400. Find the height of the prism. So I don't know H. Someone talk to me about how I would start this one. Jake, go ahead.
You just do the same thing, so like 400 equals 40 times height.
Okay, where's 40 coming from?
8 times 10.
Okay, so the base is a triangle, and my base and height of the triangle. See how that can get confusing because your triangle has a base, but the base of this whole figure is a triangle. So the base word messes people up sometimes. So the area of the base is 8 times 10 divided by 2, which is 40. From there, I would say the volume is going to be equal to 40 times H. And I don't know what H is, but I do know that V should be 400. Yep. 400 equals 40 times H. So what does H have to be?
10.
Yeah, divide by 40 if you're not sure. And 10 units is equal to H. Good? Okay, I forget what else I threw. All right, find the volume of the rectangular prism in 2 different ways. Okay. Preston, you got one way?
Well, we can do the bottom rectangle, the top rectangle.
Okay, so if I called this the base, then I would start by saying area of the base is 7 times 12, which is 84, right? And then I could multiply that by the height, which is 17. Someone help me with 84 times 17.
1,428.
Okay, 1,428, and that'd be in cubic inches. So there's one way I could do it. Now, well, Hunter, you go ahead.
78 times 7, and then you just multiply that by something.
Okay, so because this is a rectangular prism, remember we've talked about this before, that with a rectangular prism, it's hard to tell what the base is. Because, like the triangular prism we were looking at before, you had a triangle and a triangle on either end. And so those had to be the bases. But here, this is all rectangles. So if I had my prism sitting this way, technically couldn't I stand it up like this and it would still be a prism? And now this could be the base? So I can make any one of the rectangles the base here. Hunter, what were you going to say?
Could you also do 17 times 12?
Yep. Yeah, you sure could. So let's go with, I'm going to go with what Hunter said a second ago. What if I called this, whoa. It's not working. What if I called this my base? Right, I could make that the base. So area of my base now would be 7 times 17, which is 119. And then multiply that by how many there would be in the stack, which would be like this. Right, if I was going to stack those red rectangles up, that's which direction the stack would go in. So that would end up being 119 times 12. Does it come out exactly the same?
Yeah.
It should. So notice that really, here I did 7 times 12, and then I ended up multiplying by 17.
It's just squared.
Oh, thank you. See, Bryce, even I am not immune. Okay. In that first one, I ended up doing 7 times 12 and then multiplying by 17. Here I did 7 times 17 and then ended up multiplying by 12. So this is, and I don't want you to get too caught up on this formula, but I want you to know where it comes from because you've heard this before. If it's a box, okay, if it's just a nice rectangular prism box, all you're really doing for volume is multiplying the three values together. Doesn't matter how you do it because it doesn't matter which side you call the base. So if you have heard volume equals length times width times height, does that sound familiar? Okay, that's true as long as it's a rectangular prism. That doesn't work if it's a triangular prism or a hexagonal prism. Only works for rectangular prisms. Because in a rectangular prism, any of the sides could be the base. And to find the area of the base, you would do length times width, and then you're going to end up multiplying by the height. Marty? Cube, good question. What would be special about a cube? Rachel? They're all the same. So if you did length times width times height, that would work, but it would all be the same number. It would be like 5 times 5 times 5. So yeah, that would work. Hunter?
For the triangular prism, I did base times width times height divided by 2.
Yeah, that would work. Because what's going to happen there, just to talk about what he just said for the triangular prism, to find, so we have said that volume is area of the base times the height, right? Well, for a triangle, area of the base is base times height divided by 2, okay? And then you multiply by the height of the prism. Well, this here is really going to be the same as like that length times width times height thing that we just talked about, and then you just divide by 2. So yeah, you could use that if you wanted to. It gets a little tricky if you start remembering all of these different, like, oh, so for a rectangular prism I do this, and for a triangular prism I do this. So that's why I try to keep it really general. Just stick to this, okay? Area of the base times the height. Am I out of time?
No, he's
I
doing
think we're
like,
getting restless.
you have 10 minutes.
Okay. Yeah, let's just do this and then we'll be good. Because this kind of goes along with the question Marty just asked. A cube has a volume of 500 cubic inches. Find the length of one edge. Okay, so I don't know what any of the edges are, but I know all the edges are the same. right? Hunter, what do you think?
Could you divide that by 6 and then divide that by 4?
Good thinking, not quite. You could use something similar to that if it was surface area, if you were saying surface area of the cube. Caleb?
5 by 3.
Good guess, close to that. Okay, it's probably something you have not heard of before. So let's say that my side length is x, because I don't know what it is, which means all of my side lengths are going to be x. So to get volume, what would I do with all those x's? Yeah, if I wanted area of my base, well, let's do, instead of that, I'm going to highlight it up here because it would be the same. So area of my base would be x times x, right? And then I would multiply by